everyone, this is Payal ma'am here. So today we are going to discuss about electricity. Okay, so we already know, children, that electricity has become the part and parcel of our lives. We cannot even think a day or even an hour without electricity because we are dependent so much on the electrical appliances in our day-to-day lives.
The power has to go only now. It is so difficult without electricity.
Cooking is done with the help of electricity. Clothes are also washed with the help of electricity. Even vessels are also cleaned with the help of electricity.
Is it? Our district hospitals, instruments, machines like X-ray machine are run on electricity?
Yes. Can any one of you tell me the electrical appliances which get heated due to electricity?
My mother tells me that electrical appliances should not be touched by wet hands.
Uncle, we have a rod in our house to heat the water. The water gets heated in 10 minutes.
Very good. That is called an immersion rod. Due to the heating effect of electricity, water becomes hot when immersion rod is dipped in it and power supply is given.
Uncle, my mother cooks food in an electric stove. When there is power supply, then the food is cooked in it.
Very good. Due to the heating effect of electricity, many appliances work on this principle.
Uncle, isn't this the symbol of a battery? And this is a symbol of a bulb?
Like how we use a symbol for a road and danger symbols, we have symbols for various electrical components. For example, this is a symbol for bulb. This is a symbol for wire. This is a symbol for switch, etc.
This is the positive and negative terminal of a battery.
Yes, you are right. And this is a simple electrical circuit. For every appliance run on electricity, there will be an electrical circuit. We will come to know of the electrical supply through this circuit.
Okay, so children, if we can define electricity, then basically it would be the movement of the negatively charged particles, or we can say that it is the flow of electrons. Okay, so negatively charged particles have got a name for it, and that is the electrons, and that's why the term electricity has been coined.
For proceeding further, let us understand about atoms. Now, atoms are the smallest or the basic units of matter. So, if we try to break any substance further beyond atom, that's not possible. So, it is the smallest unit which makes up all the things around us.
And if we look closely into the structure of an atom, so this is how an atom looks like. Okay, so it has got a nucleus at the center, just like an animal cell is. Okay, so it has also got a nucleus which is comprising of two particles in it. Okay, the one is the neutron and the other one is the proton. Okay, now neutron, as the name suggests, it is neutral, means it is neither having the positive charges nor the negative charges, so it is neutral. Okay, so that's neutron. And proton जो होता है वो आपका positively charged particle. So P for positive, P for proton. Okay. So neutron and proton both are making up the nucleus of this atom. Okay. The next particle which we have revolving around in orbits. Now here also, like the solar system, in solar system you have the planets revolving around the sun. So similarly here also, children, you have the electrons revolving around the nucleus. So nucleus is just like that sun, and the electrons are revolving around in circular orbits. Electrons are your negatively charged particles. Okay, so the reason behind explaining all these things is that, children, we are going to mostly focus on this negatively charged particle, which is the electron. Protons aren't involved, neutrons aren't involved in electricity, but which particles are involved? The electrons, which are the negatively charged particles. Okay. Now normally when the conductors or when the metals, they are not connected to any battery or anything, then normally what the electrons would look like is over here. Okay, so this is a piece of conductor I have tried to show here. So they are without any directions, they are moving here and there. Okay, randomly they are just moving here and there. Okay, but See here, this is the sign of a switch. Okay, you have switches at your home, right? You would have also come across this switch in an electric circuit. Okay, so this switch is now open. Okay, it's not closed. Means this circuit is not complete over right now. So if I just turn on the switch, means if this switch comes in contact now, so this makes the circuit complete. So after this circuit gets complete, so all these electrons which were moving earlier without any directions, they will get aligned in one direction. I have connected this conductor with a battery, okay, and here is the switch. So switch is now open, it has been turned on, and what is happening, this is the shorter one is the negative terminal and this longer one resembles the positive terminal. So in the end of the negative terminal, the electrons are now getting aligned to one direction, okay, means they are trying to move from the negative end to the positive end. They are moving towards the positive side, okay. Electrons generally move from the negative to the positive terminal, but we say that the electric current is moving in the opposite direction, okay. Negative charges, they are flowing from negative to positive, okay, but we say that the electric current is moving from the positive to the negative terminal. Okay, what generally happens in the battery which is leading to that change in the direction of the electrons? So let us have a look inside the working of a dry cell. Okay, so first of all, why it is called a dry cell? Whenever electrolytes are there, they are mostly present in the paste form. Okay, so there is no liquid involved here in the making of the dry cell, and that's the reason it is called as dry cell. Okay, now if we look at the various components of a dry cell, then we come to know that if you know what a dry cell looks like, this is a dry cell. Okay, you must have all used it in our remotes or whatever toy cars and all. We get to see all these types of cells. So this is an example of a dry cell. So if you look over here closely, this cap-like structure, so this is known as the positive terminal of the cell, and this end, the flat one, okay, so this is the negative terminal of this cell. Okay, so the same cell with the internal structure of this dry cell has been drawn over here. Okay, right now please don't concentrate on what has been given on the right side, so just go through this diagram. Okay, so in this diagram, children, you can see here the same, that cap like thing. So that is the positive terminal, and that positive terminal is made up of your carbon rod. Okay, so inside this cap there is a rod in the center which is your graphite rod, or it is simply called as the carbon rod. Apart from this, there is this ammonium chloride. This ammonium chloride is acting as an electrolyte over here. Okay, remember this, it is the electrolyte. Okay, you need not go so much deep in what is electrolyte and all, children. Just for remember it for now, electrolyte. Okay, once you go to your higher classes, you will come to know more in details about all these things. So I'm not trying to confuse you more into this. So just I'm briefing you about what each thing is doing here. Okay, so carbon rod I have already explained. Now manganese dioxide, okay, manganese dioxide is also there over here, which you do not have to focus more on right now, because this also you are going to study in the higher classes. Okay, now this zinc case, what is metal what you see over here, this is basically made up of zinc. Okay, and this zinc is leading to the negative terminal. Okay, now why we are calling this as negative terminal and this gap side as the positive terminal, that we'll come to know if we look at this diagram here. Okay, so whatever chemical reactions are going on inside the dry, you know that battery it converts the chemical energy into electrical energy, right? So here whatever chemical reactions are going on, after this what happens, at this end, okay, towards this end, there are more number of electrons getting concentrated. whereas on the top portion there is deficiency of electrons over here. Okay, so here in this negative end, why we are calling this negative end? Because more of electrons are found here, and electrons, as you know, they are negatively charged. So where there will be more negatively charged accumulating, that end will be known as your negative terminal. Okay, that's why we call this as negative terminal and this cap side as positive terminal. Why positive? Because here there is deficiency of negative charges. So if there is no negative charge over here, then it will be what? Positive. And here, since it is more of negative charge, then it is what? Negative. So this is the negative terminal, or it is also known as anode. Okay, and this is the positive terminal, which is also known as cathode. Okay, sometimes it gets very confusing as to which is anode and which is cathode. Okay, तो हिंदी में बोलते हैं ना अनाड़ी, अनाड़ी जो नेगेटिव, जो कोई काम का नहीं होता, अनाड़ी एक होता है खिलाड़ी, एक होता है अनाड़ी. Okay, so this anode is your anadi, is the negative one. Okay, other one you can already remember, negative ka ulta positive. Okay, so that will be your cathode. Okay, this is a simple trick. Now in between there are these electrolytes which is your ammonium chloride. Okay, so after the reactions going on inside the dry cell, these three types of partitions occur. One area, the negative terminal comprising more of electrons, this area deficient of electrons, and this center portion is occupied by the electrolytes. Okay, and these electrolytes will prevent the transfer of electrons from this portion to this portion. That's why, that is the reason why we add the electrolytes. Why? Because we want to create a difference inside this cell. Okay, now dams what they do? They store the water. Okay, and once there is deficiency of water crisis, then what they do? They open the gates and that water gets released. So same way, this is also like a dam. Okay, so this is storing all the electrons in it, and this electrolytes is like the dam's gate, which is preventing the flow of the electrons from this side to this side. Okay, so this we call it as potential difference. Means इसमें बड़ा ही potential है move करने का, and यहाँ पे क्या है? Potential is zero. We have already understood that what reaction is taking place inside the dry cell. So I already told you that towards the negative terminal, the concentration of the electrons are more, which is making it the negative terminal. Okay, and here there is deficiency of the electrons. Okay, so now here in the between there are the electrolytes. So the negative charges cannot travel within. So the charges will have a tendency to move from the negative towards the positive terminal. So in this conductor, these electrons will come out and come to this conductor. Okay, the electrons will move over here from this end and it will go towards the positive end. I told you already that earlier they were all moving directionless. Okay, they were moving in random fashion here and there. But once it is connected to the cell or the battery, they all will have a tendency to move towards the positive end. Okay, and hence this part will be now getting the electrons slowly. Okay, so once all this electrons is emptied into the positive terminal, till then the battery will be working, and after that we say that the battery will die out. Okay, when every charge will be already conducted to this end. Okay, and that's why these types of cells are known as your primary cell. So primary cells are those cells which cannot be reused or recharged. Okay, the battery which we have in our cell phones, okay, they are all example of secondary cell. Why they are called secondary cell? Because secondary cells can be recharged and they can be reused, but unlike these batteries. So these cells, that's why they are known as primary cells. This pathway, if we connect a bulb, okay, a bulb will start glowing. Why? Because the electrons are flowing in this circuit, and that electrons will make this bulb to glow, and that's how we form a circuit. Okay, in your home also, whatever electric appliances are being used, they are also part of this circuit circuit only. Okay, they are also being kept within the circuit. You switch on an appliance means what? Here the circuit is getting complete now. Okay, earlier the circuit was open, now it is closed, and when it is closed, it is allowing the smooth transfer of the electrons from one end to the other end, and hence it is completing the circuit. And that's how whenever you join any bulb or anything, any electrical appliances in this circuit, they will also start functioning. Okay.
Children, there are certain materials around us which do not allow electricity to pass through them, or which resist the flow of electrons through them, and those materials are known as insulators. Okay, or we can also call them non-conducting materials because they do not conduct electricity. On the contrary, there are certain materials which allow the free flow of electrons through them, or which are capable of conducting electricity, and those materials are known as conductors. So here we will watch a video where we have created a circuit and tried to test the different objects around us to see whether they are insulators or non-conducting materials, or they are good conductors of electricity. So children, you can also create circuits like this at your home, and you can also test for the various materials to see whether they are insulators or conductors. Electrical circuit using these following materials, which are a few conducting wires, a scissor, sellotape, port pins, and a safety pin, a rubber band, a battery, and a cell. So as you can see here, we have used the safety pin for the purpose of creating a switch. Okay, so when this switch touches the board pin, then it completes the circuit and the bulb starts glowing. And when the safety pin is detached, then the bulb stops glowing. So here you see the circuit is being completed using the safety pin. So same way in your house also, whenever you switch on the switch, then what happens? The circuit gets complete like this, and your appliances start working due to the flow of electrons within them. Trying to see the different household items to see whether they are conductive or they are non-conductive. Non-conductive can be also called as an insulator. So iron nail, since it's made of metal, so it conducts the electricity and the bulb starts glowing. So here the pencil doesn't conduct electricity because it is made up of wood. Now next we will take a key which is made up of iron, and once we put two clips like this completes a circuit, and hence the bulb starts glowing, which shows that the iron key is a conductor. Okay, so similarly we are now going to test a plastic bangle like this. Okay, you can take a plastic or a glass bangle. So when we put the both ends of conducting wires like this, then we notice that this doesn't conduct electricity. Now we'll take a coin. Okay, so this is also a metal coin. So if we try to connect this, we'll see that the bulb starts glowing. Okay, so this is also a conductor of electricity. So same way children, you can also create a circuit like this, and you can test various things around you at home to see whether they are conductors or insulators. Now we'll take an eraser, okay, and see whether it is conductive or non-conductive. So it is non-conductive, it's an insulator, so which will resist the flow of electrons within them. Okay, so this is again a plastic material, so this is also not conducting the electricity. Now we'll take nail cutter. So nail cutter is also made up of a metal, so this is also conducting electricity. So now next we'll check the screwdriver. Okay, so when we are connecting it with the metal end, then it is conducting electricity, and when we are connecting it throughout, I mean one end with the insulator, then it is not conducting electricity because the handle is made up of plastic. Now here we are taking a straw. Okay, so this also proves to be non-conductive. So this is also an insulator. and we will check the metal part whether it conducts the electricity or not. Yes, it definitely, because it is made up of metals. And when we test it throughout the body of the scissor, means connecting it with the plastic handle also, then it doesn't conduct electricity. Handles are generally made up of insulators to prevent us from getting shocks or prevent us from feeling the heat of the materials. So children, if you really like this video, then please give it a thumbs up and do share it amongst your friends. And if you haven't subscribed my channel yet, then please hit on the subscription button and the bell icon as well in order to get the notifications first.